In this lecture, I'm going to show you how to use the player animation blueprint to control the idle and run animations for the player. Let's open the player animation blueprint we just created. We can do this by selecting the animation component in the BP player. Go to the animation instance class on the right side. Then hit this button to locate the file in the content drawer. Then we can open the file. We have the event graph here and the animation graph. We are going to use this event graph later on to manage the variables for the animation blueprint. For now, let's jump over to the animation graph. Here's where we manage the animations. This one is the final output node that controls the animation that is on the character. For it to work, we need to create a state machine. Let's search for add new state machine. I'm going to call this state machine locomotion and connect it to the output. So this locomotion state machine is where we manage the animations for the player. Let's click on it to get into it. Now we only have an out node, and we are going to create different states for different animations. You can right-click and select animation state. For this state, I am going to call it idle. We are going to set up the animation that we want to play in the idle state later on. Here I'm going to create another state and call it run. Next, we need to set up the control flow for the states. Let's connect the out node to the idle state. This means when the game starts, the idle state is going to be the default state. Alright, let's test the game. You'll see nothing is going to happen for now. That's because we haven't told the animation blueprint which animation we want to play when in the idle state. Let's get into the idle state. We need to tell this state to play the player idle sequence. To do this, you just need to search for play player idle. You are going to have this option because we've created the sequence file. Let's connect this node to the output. You might be wondering why we need so many steps to just play an animation, because a lot of times you might have multiple animations for the same state. And this setup is going to allow you to add more logic to select from different animations. I'm going to demonstrate that part later on. For now, let's just press Alt plus P to test the game. Alright, the idle animation is playing. Alright, let's go back to the root graph of locomotion. Let's get into the run state to set up an animation. Right-click and search for play, player run. Connect it to the output. Then go back to locomotion. Let's add a transition from the idle state to the run state. Drag from the outer area of the idle state to the outer area of the run state. Alright, now we have the transition here. If you click on this icon here, you can set up the rule for the transition. Here we need to define under what condition we want this transition to happen. From this specific transition from the idle state to the run state, we want to know the velocity of the player, so we can know if the player is moving. Then we just tell this transition to happen when the player is moving. To get the velocity of the player, let's go back to the event graph. The key point is that we want a local variable inside this animation blueprint that represents the velocity of the player. This event on init is going to happen when the game starts. Let's get the velocity of the player with this event and make it a variable inside this animation blueprint. Let me briefly switch to the player blueprint. This character movement component contains the velocity of the player. Go back to the animation blueprint. Let's search for get owning actor. This is going to give us the actor that's using this animation blueprint, which is our BP player in this case. But if you drag out from it and search for the movement component, you are not going to get it here because the movement component is only a part of the character class. And here what we have is just an actor class. So first we need to convert the class from actor to BP player. We can use the cast node to do it. Search for cast2 BP underscore player. Connect event on init to this cast node. And the output here is going to be the right class that we need. We can drag out from it and get the movement component. Select the get movement component function. Then we want to keep the return value, which is the movement component, as a local variable. Right-click on the return value. Select promote to variable. Now we have a new set node and a new variable on the left side. Let's rename it to movement component. Notice that the engine has determined the type of the variable for us, which is the correct one in this case. Alright, we also need to connect the cast node to the set node. Otherwise, the new variable is not going to be set. Now we can compile and go back to the transition. We need to check the velocity of the player with the movement component. Let's drag the movement component into the graph. Then we get velocity. Select this one under variables. Next, let's get the length of the velocity vector. If the length of the velocity vector is bigger than 0, we know the player is moving. Let's use the greater function to check. We can leave the other input as 0. Then we connect the output, which is a boolean, to the result node. Let me rearrange the nodes. By selecting all of them and pressing Shift plus W. We are done here. Let's compile. Now let's run the game to test. We start with the idle animation. Then we switch to the run animation when we move. But the animation doesn't go back to idle when the player stops. This is because we haven't set up the transition from the run state back to the idle state. Before we leave here, we can copy these nodes, then go back to the locomotion state machine. Let's create a transition from the run state back to the idle state. Then let's manage the rule. Let's paste the nodes we just copied. Let's remove the last node. And this time, we are going to use the equal operation with the return value of the length node. In this case, we are going to get a true result when the player is not moving. Let's connect the Boolean output to the result node. Alright, now we can test the game. Great, the animation worked as expected. And that's all for this lecture.